In this mini lecture for Module 7, we're going to be looking at two sample designs, and in particular, we're going to be looking at the logic behind the Wilcoxon signed rank test. This is used instead of the paired sample t-test when our data violate the assumptions of normality. Now again, similarly with all of the other statistical tests, we have these 4 different steps that we follow, and because we're dealing with a non-parametric test, we're looking at the sampling distributions based on ranks and not quantitative scores. There's also quite a simple procedure involved with the Wilcoxon signed rank test. Remember back to the paired sample t-test, where the null hypothesis is that the mean difference in the population is equal to 0, and that the alternative hypothesis is that the mean difference in the population is not equal to 0. Well, now we're dealing with ranks. We're going to be ranking our data, and we're looking at medians. Here's a study looking at heart rates 1 minute after a traumatic experience and 5 minutes after, and you can see the data there. The steps that we're going to follow are going to be, first, figure out the differences. We're going to take 1 minute after and subtract 5 minutes after, when heart rate may have returned a little bit back to normal. Then we're going to calculate ranks based on the absolute value of the differences. We're going to adjust for ties, and then finally do what's called a signed rank, where we're going to put a negative sign if the difference was negative. So here's the data that you can see here. Take a minute and have a look. You can see with this data that most of the values are positive, and we only have very few negative values when we look at the differences. So then we rank them regardless of the sign of the rank, right? So you're going to start, number 1 is assigned to the value of 1.5, and the value of 10 is for the greatest difference of 8.4. We adjust for ties. You'll see there's 2 differences that have values of 2.2. One of them is actually positive, one of them is negative. They're given the ranks of 3 and 4. When we adjust for ties, they both get a rank of 3.5, and then the signed rank is either positive, that difference was positive, or negative if the difference was negative. And what we're doing with the Wilcoxon signed rank test, basically with our null hypothesis, we're saying that there's no tendency in either direction. So the magnitude of the positive and negative signs should be approximately equal around 0. Right? So with our null hypothesis, we're saying, is the distribution centered around 0? Is the distribution of the differences, that's what we're interested in a paired test, is the differences, is that distribution centered around 0? So if the median difference really is 0, the negative differences and positive differences should be equally likely. So then we compare the sum of the positive ranks and the sum of the negative ranks. Again, if there's no effect, these should be equal, and we wouldn't have a difference from 0. From the data that I showed you, if we sum the negative ranks, we get a value of 6.5, and the sum of the positive ranks is 48.5, suggesting perhaps that shocking experience increased the heart rate 1 minute after it, and then it went down lower 5 minutes later. Again, this is what we see from the data. Again, I just want you to understand the logic of this. You would take the smallest value, go look in a table, and determine whether or not it was statistically significant. I'm just going to tell you that it is, and so we would conclude that the heart rate was significantly greater immediately after the event. And of course, our alpha value is 0.05, so our p-value is less than 0.05. When we talk about assumptions, for this test, we're assuming that there's a symmetrical distribution of differences around the median. This is different from in the paired sample t-test that assumed there was a normal distribution around the mean. On the left-hand side, we can see that the distribution is not normal, but it peaks up in the middle, and it's symmetrical on both sides. And on the right-hand side, we have a rectangle distribution about the median. This is an assumption of the Wilcoxon signed rank test, and you can follow up this with the reading in Whitlock and Schluter.